So I'm very happy to introduce Pierre. Pierre Depaz is a scholar as well as a developer and an artist. Is currently a lecturer of interactive media at NYU University in Berlin and a guest lecturer at Sciences Po in Paris. His research revolves around the way software systems create representational frameworks, and today is going to talk about this software, generative pre-training transformer 3, created by OpenAI, that most of you must know already. Thank you very much, Pierre. Up to you.
Thank you, Marita. Thank you for the introduction. One last point I would like to mention is that I have the pleasure to work on a doctoral thesis under Alexandre Geffen, and this doctoral thesis is on the aesthetics of source code. And so when I'm thinking about GPT-3, the question I have first is, what exactly is GPT-3? So what I would like to do today is to go through a history of approaches to AI, and specifically comparing two styles of AI research, and how the style connects both the research and the implementation. The style that the concept of style that I use here is taken largely from Gilles Gaston Granger's essay for a Philosophy of Style, and he theorizes it as a way to think through relations between theory and practice. Style is a structuring unit, and it's a way to formalize the lived experience into a thought, and on the other side to help manifest a concept or a set of concepts into practical realizations. So style as a structuring unit is something that both works of art and or rather works of science and works of fiction have in common. It's a way to make the somewhat unintelligible, what Polanyi called the tacit knowledge, graspable and expressible. In science, you have the style of starting a demonstration with the phrase given X. In fiction, you have the style of starting a story with the phrase once upon a time Y. And those fictions, I take a broad definition of fictions, and specifically those of Gérard Genette, and this idea that fiction is really just what particular cultural traditions, hypotheses, belief systems, and reader positions allow. And these can change over time, over space, and over social groups. So we'll see how this dovetails into AI research. The hypothesis, though, is that fictional environments manifest themselves into concrete practices, tools, and active realizations. And those fictional environments have real consequences, not just as the way that it affects the way we think, the way we act, but what we do with the tools that we create. As a practicing programmer myself, the tools that I deal with most of the time when I deal with AI is programming languages. So these are the two styles that I want to look at in terms of those programming languages. We're going to go into two branches. There's going to be the style of atomic language manifested into the programming language Lisp, which then sort of culminates into the application Schrlu, which I don't think the name was ever meant to be pronounced. And the second style is the landscape language, with manifested then into Python, C++, and CUDA, this sort of trifecta, and which then brings us to today's topic, GPT-3. So as you can see, it's a little bit broad. I will try and keep it as short as possible. Both of these started the Dartmouth workshop. So I'm assuming everyone in the audience is familiar with it. The Dartmouth workshop takes place in 1956. It's proposed by John McCarthy. John McCarthy is the creator of Lisp. So the creator of the Dartmouth, the initiator of the Dartmouth workshop is the creator of our first language. That's in collaboration with a couple of other people, mainly Claude Shannon that you see at the top here, Newell and Simon, economists and programmers in the middle, and two other individuals, Warren McCulloch and Marvin Minsky. And we'll particularly look at what Warren McCulloch had to say about AI. Because when they talk about AI, they don't specifically talk about language. And when we talk about GPT-3, we talk about language. This is an excerpt from the Dartmouth proposal itself, and the idea, the intent, and the reason they wanted to have funding was how to make machines use language, form abstractions and concepts, solve kinds of problems, now research for humans, and improve themselves. And as you can see, language is a part of it. Language is not the basics, but it's somewhere in there. It's not explicitly said that we're going to solve language, and therefore we're going to know how to have ideas. So the first attempt is this idea. This first style is language as symbols, and that comes from a more formal scientific tradition. This is sort of Bertrand Russell rediscovering likeness, and then inviting Wittgenstein to come and work with him at Cambridge. Wittgenstein then teaches Turing at Cambridge. Turing both works on problems of computability at the same time as around the Church. Church has this theory of lambda calculus. Lambda calculus is what influences Lisp. So we have this sort of clear connection here. And what I would like to spend a second doing is looking at what kind of style do they think in order to manifest their thinking with. The first one is the symbol. Particularly in Leibniz's work, this idea of being able to encompass, to extract from a complex real environment ideas, and then being able to have them self-contained. He also thinks about diagrams. He presents diagrams, but they have limited connections, and the focus is really more about the atomic unit, the unary, or the monad, than he uses in his philosophy, rather than what they mean together. Because what he wants to do with it is he wants to do math. And so this is a quote of him talking about his Characteristica Universalis, and he says, ideally, we should be able to reason in metaphysics and morals the same way as in geometry and analysis. So if controversies were to arise, there'd be no more need of disputation between two philosophers than between two accountants. Let us calculate. This is sort of the goal. This is perhaps a fictional dream that he's setting. But from symbols, when Russell rediscovers him, and when he initiates predicate logic with publishing Principia Mathematica with Whitehead, they don't focus so much on the single symbol, but on the proposition itself. There's a need to connect the symbols such that if you're saying something like A is the B to the C, then it's not just A, B, and C are not completely separate and disconnected, but they're all together. So we're starting to have an expression that is a new building block, so to speak, from just the symbol by this idea of the proposition. And this connection happens through another stylistic means, which is the list notation. So, for instance, we see here an extract from Leibniz's demonstration of the existence of God in a list format: 1, 2, 3, 4, 5, 6, 7. Then we see Gottlob Frege's Begriffsschrift, which was an attempt at having, again, a new notation for thinking. I will not attempt to pronounce the full title in German. And then finally, the Tractatus Logico-Philosophicus of Wittgenstein, again, in a list manner. So the list is a way to organize these atomic units. These propositions should be able to stand on themselves, but you need to connect them in a way in order to form a bigger whole. And this is what they use, the list. So what is the style of the list? The list making, and this is Jack Godey in The Domestication of the Savage Mind, says that it's an example of a kind of decontextualization that writing promotes, and one that gives the mind a special kind of lever on reality, so that the way that you organize the world, or you organize your thoughts about the world in a particular graphical style, affects how you understand the world. And this graphical style, in the end, the list is abstract. It is made of bounded elements. They don't overlap or they don't touch each other. It is discontinuous, and there's a potential hierarchy. You can have ordered list, you can have unordered list. So there's a potential to it, but there's no forcing to it. So that we get to this point until 1940s, 1950s, and then when we have this new thinking for a language of thought, for logical propositions, computers come around, and what computers are good at, and this is what Galloway says, is that code is language that executes. Code can make things happen, and so the attempt was then to manifest these ideas represented in a certain style into an actual tool. And this tool is Lisp. Lisp stands for Lisp processor. It's based on Litterature lambda calculus. It was designed by McCarthy in 1956. The interpreter was written in 1956, the compiler a couple of years later. And it is so-called the language of AI. When you read about Lisp in the circle of programmers, the Lisp has this aura of sort of perfection, of a way to break a means to break the mysteries of the human mind. It did not come from nowhere. It was preceded by Simon Newell's information processing language, which again, this is an excerpt from the manual, is about list structures and symbols. It's about manipulating very, very simple basic units, and the idea that you can, starting from basic building blocks, you can construct more complex wholes. Lisp has this fascination for programmers because everything in Lisp is under this form. This is called an S expression, and you take an operator on the left, and then you have as many arguments as you want. And then the operator can be a list itself, an argument can be a list itself, or a symbol, or an empty list. It's as simple as this. Another fascinating thing about Lisp, something that comes again and again in literature, is this piece of code, and it fits perfectly on my screen. This is a Lisp interpreter written in Lisp. One of the problems in computer science, possibly electrical engineering, I don't know that much about it, but is how do you start? When you push when you turn on the button on your computer, how does it know how to read data? How does it even know what data is? So it's this problem of bootstrapping, and this is the piece of code in which Lisp bootstraps itself. Lisp interprets Lisp and can make things happen without anything else beyond a computer. And this creates sort of a fascination of programmers for this idea of like self-referentiality, autotelism. It doesn't need to refer to anything else in the world. It just needs itself, and it has this sort of pure beauty to it that appeal to the logical mathematicians. So this is the design of Lisp. What are some of the applications? The first applications are logical problems. So the IPL, the information processing language, for which Newell and Simon won the Turing Award in 1978, was meant to solve where they had two software called the general problem solver and the logical theorist. So the idea was like, okay, we can make machines think, but we can make machine things within the realm of logical philosophy. Here's a short parenthesis about this kind of work, because a lot of it was done in PhD thesis, which probably students around the age of 22 to 26. And then we have on the first line a dedication from I don't have my notes here. I can't remember whose it is, but it's a PhD thesis from supervised by McCarthy that says that is dedicated to the descendants of the Maharal who are endeavoring to build a golem. A lot of maybe early adult hubris. In that same vein, a lot of those programs are given anthropomorphic names. They're called soldier, they're called doctor, they're called student, saint, quite dramatically. And then follows perhaps the most known one, Eliza. Lisp also attempts to understand the world. It's this idea of language not as a way to express yourself, but as a way to understand, as a way to form concepts. And so another area of research is considering language as children, or rather children literature as language. This is a thesis by Eugene Charniak, who was working under Marvin Minsky, and he, in order to understand the world, he needs to reduce it to the simplicity of children's literature, and perhaps that echoes Wittgenstein's third book, the alphabet book for children. And then it culminates into a program called Schrödlu. Schrödlu was this idea of confronting the style of artificial intelligence manifested in Lisp with the real world. What the real world was considered as boxes and triangles, as you can see here on the screen. And the idea was that you can interact in natural language. You can say, pick up the red block, and the computer should be able to know what the red block is. And then you have blue boxes, and then you have a green triangle, and it's all very colorful and beautiful. The image below is the syntactic tree for the organization of Schrödlu, and that echoes in another style that I don't have time to go into, but in 57, I believe, is the publication of Chomsky's syntactic structures. And so the conception of language is closely mimicked onto Chomsky's generative grammar. How successful was Schrödlo? Not so much. This is a quote from Terry Winograd, his creator, in 2004, who says that there are fundamental gulfs between the way that on the one side Schrödlo and its kin operate and whatever it is that goes on in our brains. I don't think that current research has made much progress in crossing that gulf, and relevant science may take decades or more to get to the point where the initial ambitions become realistic, and the initial ambitions again are to be able to form abstract concepts and to be able to learn. So Lisp in the end in this approach was intended to solve toy problems, what Minsky calls toy problems, very simplified versions of the world. And very quickly in the commercial world, it was defeated by combinatorial explosion. There were just too many things to look into, and Lisp was too slow to get the job done. So meanwhile, there's another approach, which is languages matter, which posits that languages exist in the brain and the brain's materiality cannot be ignored. And one of the proponents of this approach within the greater circle of seven mentions is Warren McCullough. And Warren McCullough has a couple of texts that he published by being part of the Chicago Literary Club. And instead of, while McCarthy stands very much in line of this long tradition, McCullough stands against. And the traditional psychologist at the time, or neuropsychologist, is Freud. And so he says that like Freud's data and method and theory are indissolubly one. So the way that Freud interprets the world is the way that Freud's theory is being manifested, and this is to him not good science. For him, in order to understand what is happening in the brain, if we are to have any knowledge of the world, there must be nervous impulses in our heads, which happen only if the world excites our eyes, our ears, our nose, our skins. There must be input-output, in other words. Because the whole is conceptually inseparable from the parts. We cannot extract meaning from the world the way Leibniz intended to do it with symbols. We need to manifest it in its concrete aspects. And to see how this prefaces GPT-3, this is this conception of language as a continuous stream. This is from The Natural Fit, another text he published, in which echoes very much how machine learning works today. Like he says, for instance, in spoken English, sequences of words are so familiar that having heard some, we rightly hear the rest and understand with half a mind and half an ear. Words that we know we have anticipated, we find only when their sense is unexpected, when we're taken by surprise, in other words. More often we encounter something that at most recalls the words that we had imagined. So there's this part of the imaginary, there's this part of nothing is really explicit, but it's already there and it just needs to be activated rather than declared beforehand. So there's this idea of input-output, there's this idea of continuous stream in the way that he expresses his thoughts in this sort of elegant prose. Is one stylistic approach. The other one is spatial notation. So when we had propositions, when we had symbols in lists in the first approach, now we're seeing diagrams, perhaps back to Leibniz. This is another paper by McCullough in which he attempts to prove that the brain is a Turing machine. It's logical calculus for nervous activity. This was his research agenda when he went to the Dartmouth workshop in 56. And here the interaction is more complex. It's building logic gates out of neurons. He also works on the piano notation, which takes the truth tables, linear truth tables that are used in computers and specializes it so that it can be superimposed. And then finally, in what is going to bring us into the new programming languages is this paper on what does the frog eyes tell the frog's brain, and it's a neuropsychological investigation into how does the brain process signals, and they realize that the brain doesn't process all signals. Actually, the eye processes signals as well. The input mechanism is as important as the processing mechanism, and the brain alone is not sufficient. This here are the signals, the electrical signals, which announce the need for cleaning up data through like noise reduction, softmax, and so on. What does the diagram do as a stylistic choice? Sibyl Kramer writes that they're a point of linkage between thinking and intuiting. They're between the noetic and the aesthetic, between what we can think of and what we can see. Non-visual objects and theoretical entities, such as language, can be spatialized, can be made intuitable and manipulable. And so there was already an attempt in logical approach to language to manipulate it, but the intuition perhaps is going to work through GPT-3. Through this importance of space, through this need of, or this requirement of input and then output in order to understand, language, the system, is depicted as always embedded in the world. Language is part of where we are constantly and is manifested in concrete realizations. It's not just this abstract thing that we can theorize. In 1956, the attempt is to do it through a machine called the perceptron. This is a picture of Frank Rosenblatt working on his perceptron in 56. Perhaps he was too busy debugging the cables to attend the Dartmouth workshop. He wasn't there in any case. And a commentary by Marvin Minsky on this approach, saying that yes, it is a good idea, but it's not feasible due to very specific technical issues. We jump 60 years, 40 years later, and the technical issues have been solved through programming languages. And those three are Python, C++, and CUDA, who give us today GPT-3, and I consider GPT-3 as a material AI. So just to recap briefly, what is GPT-3? It's a deep learning model. It's based on the transformer architecture, has been given a lot of amounts of data, and it's too good at it's really good at two things. It's really good at translation, and it's really good at text generation tasks. Very different from what Lisp was supposed to be good at. Lisp is supposed to be good at understanding. GPT-3 is actually quite bad at understanding anything. And how does it work? It works through machine learning, which embodies the psychological approach. It's about probability. It's about recombination. It's about inputs and outputs. It's a very practical approach to the problem. It's about getting the job done. And so, this is the transformer. This is the transformer architecture, and this was published in a paper called "Attention is All You Need," because they have this attention mechanism to which every word is related to every other word in the text document. There are two things I want to point out here. One is that clearly there's an influence on the diagram and on the sort of cybernetic approach to it. Second is that GPT-3 is only different than GPT-2 in the sense that it just has more. Again, an argument for the material aspect to it. If you just give it more, you will have a different result. There's it's a difference of degree rather than a difference of kind. Whether our interpretation is a difference of kind is a different question, of course. So Python in this case is not really a specific language. It's what is called today a scripting language. It doesn't really have a style. It doesn't have a paradigm. Lisp has a strong style. It created this paradigm called functional paradigm. It has a really incredible stature in this position amongst programmers. Python not so much, because Python is what we learn when you take your first class of computer science at university. This is an example of a very popular comic amongst programmers, in which someone dreams and thinks that God made the world in Lisp, but really they made it. They hacked most of it with Perl, and Perl and Python have this reputation of being glue languages. Like when things don't fit together, you put them together with Python and Perl, and then it works. Switching styles, Gaston Danger had this thought about sometimes when you switch styles, what you lose in rigorousness from Lisp, you gain in efficiency into Python. Python has three reasons for which it manifests this new style. It has data frames. Data frames are not linear single processing. It's things happen simultaneously. You get a bunch of data at the same time, and you can process it all at the same time with this new kind of hardware, GPUs. And what is the language of GPUs? It's CUDA. What is the fastest language in CPUs? It's C++. And so Python is just this binding of, or GPT-3 is rather this binding of multiple languages. The same way that Macculloch's understanding of the mind was this binding of multiple organs, which each have their own processing methods. And then finally, Python is easy. Anybody can work on Python. If you look at the Python implementation of TensorFlow on GitHub, it has 80,000 stars, and I don't know how many contributors, but a lot of people can work on this project, and the sort of peer production of value definitely played a part. Yeah, to the point, this is the Python code you need to start working with GPT-3. The biggest issue is not the programming language knowledge. Biggest issue is getting access to it and having an API key from OpenAI. So Python styles, to sum up quickly, it allows us to represent the world and the language as highly dimensional input data. I'm not going to go into how text is vectorized. There's a presentation by Pierre, who's really good and really insightful into this. But the point is that now we can build text into space. We can make word vectors. And so this brings us to what we're reading today, right? To what we're reading in GPT-3 and what I consider being sort of text as landscape. It's a continuous stream of input. It doesn't really have any semantic distinction. It just has positions. And by virtue of a translation of a reference, we can navigate it. And it turns out that we can navigate it quite well. It's not really quite clear what is the reasoning or the scientific justification as to why that is. The reality is that we can. And turns out we're quite satisfied with it because it's the effectiveness. The speciality I ask myself is whether it is a feature of the digital or a feature of language. The first one is a screenshot from the AI Dungeon, which has been mentioned a couple of times during these couple of days. The bottom one is Colossal Cave Adventure, one of the first interactive fictions and video games on the PDP-10 in 1972 or 3. And it's both about natural language processing to explore different spatialized environments. And Janet Murray and Hamlet in the Holodeck goes as far as saying that one of the particular defining elements of digital environments is the spatiality, the fact that we can get lost somehow. So perhaps it doesn't say anything about the nature of language, but it says something about bringing a concept into the digital world, spatializes it, perhaps. What GPT-3 also is, according to me, is that it's a snapshot of what was. It really does not produce anything new. It just fills gaps with existing, with what has been trained on, and to some extent, it could be a Dadaist poem. This is from Tristan Sarah, and he explains that how do you make a poem, a Dadaist poem? You take a journal, you cut it up, shake it, put it back together, and then it has meaning. And it has meaning because we read it. It doesn't have meaning because the bag gave it meaning. It doesn't have meaning because GPT-3 gave it meaning. The consequence of having this is that now we have to deal with papers like this. Man is to computer programmer as woman is to homemaker. We realize that this is not particularly in Common Crawl, but it is in another data set called Word2Vec, in which if words are in space and if this sort of meaning emerges from space, then the direction from man to computer programmer should be the same direction as woman to computer programmer. It should be the same vector, it's the same relationship. If you ask Word2Vec or explore Word2Vec, you realize that if you go from man to computer programmer, and you start from woman, then you end up with as homemaker because men are programmers and women stay at home, according to the internet. So what I really think GPT-3 is, and I'm about to conclude on this, is that it's a prosthetic organ for literature. And I'm borrowing this idea from David Rockaby as the computer for a prosthetic organ for philosophy, in which it only asks the questions back to us. To me, it doesn't go beyond any human abilities. It just reflects it reflects our particular habits to us. It reflects our patterns of writing. It reflects our ideas of authorship. GPT-3 really isn't writing human text. It's writing things that are on the web since 1990s. If you're not on the web, you're not in GPT-3, and you will not be able to know what it is because it's a deductive model rather than an inductive one. And so coming back to a side note on the different perception of style is that how does the individual match in there? Georg Simmel has this idea of style as a structure between the individual and the collective, and how at some point some individual achieves something unique and then gets copied by the others. And that I think is an interesting way to think about GPT-3 and about a sort of collaboration with GPT-3 is that if we write better, if humans write better, GPT-3 will write better. And will be this sort of positive feedback loop in which the GPT-3 is fed by our writing, and quality writing leads to quality machine learning. So to wrap up, I've attempted to show that style provides the connection between the theoretical fictional assumptions of science and their concrete realizations, and specifically in programming languages, and that the way we do things do affect what we want to do. And in the end, to me, that would perhaps be a little bit fun for Turing, is that GPT-3 doesn't really create anything out of this material conception. It is just about imitation. And I'm not quite sure how this imitation relates to whether or not it is intelligence and whether or not it is creative. And I think this is a question for us to answer. Thank you.